This is Deno code. Well, technically, it is TypeScript code running on a Deno platform. As a result, it enjoys a handful of additional benefits, ranging from support for the latest ECMAScript features and web APIs, to a powerful standard library which covers most of your basic needs. At its core, Deno is a JavaScript runtime, but don't hold this against it. People spend a significant amount of effort to make JS performant and efficient, even in cloud and edge computing environments. So let's go ahead and look at this code snippet in more detail. Make sure to stick around until the end, because we'll end up rewriting this file-based implementation using one of Deno's best features, Deno KV. Follow the documentation instructions to install Deno locally and then initialize the project. For future reference, Deno has first-class support for TypeScript, so we don't have to worry about compiling TS into JS. As a result, we can simply execute any TypeScript file using the Deno run command. Since Deno is secure by default, and we will read and write files on the disk, our intention to perform I/O operations needs to be clearly specified. Back to the snippet, the first thing you need to know is that this code will be directly executed line by line. No need for a main method or any other type of entry point in our program. Okay, first I'm defining a member structure using the interface keyword. Here, we could have also used either plain JS classes or the type keyword. There are pros and cons to each approach, but most of the time it all boils down to your own preference. Then, I'm making sure the member email and name are correctly sent as arguments. Deno args is a list of strings, and we can destructure it to extract the values for easier access. Next, let's take a look at the getMembers function. Reading files from the disk can be a time-consuming operation. As a result, the readTextFile Deno method will return a promise, a construct which will produce the file content sometimes in the future. We can either handle that content response in a callback or use the await keyword to simplify the syntax and avoid a potential callback hell situation. Any function using await in its body needs to be marked as async. The rest of this function is pretty self-explanatory. We are splitting the content into multiple lines, avoid working with empty or corrupted lines, extracting the comma-separated values, and then converting the resulting split array into a member object using object literals and the shorthand syntax. With the member list available, we can make sure that the new email is not present in the member list, update the list, and then store it back into the members.csv file. Pretty straightforward, right? Well, we can do way better using Deno KV. This will allow us to move away from storing data in files on the disk, which is really not that scalable, and move our members into a state-of-the-art, scalable database, which is natively integrated into the Deno platform. So let's start from scratch, extract the member data from the passed-in arguments, and then open a connection to Deno KV. As the name suggests, data in Deno KV is stored as key-value pairs, where the keys are arrays of strings, numbers, or booleans. We'll prefix our key with the member keyword for reasons which will be obvious in a second. Then, we can check if the key is already stored and perform the update otherwise. Keep in mind that in the real world, multiple users can access the database at once. With multiple threads running, we can easily run into a race condition. So the proper, thread-safe way to handle conditional inserts in KV is to use a transaction instead. Finally, thanks to the key member prefix, we can easily extract all the members already inserted into the database. If you found this video useful, you'll probably like some of the other videos on my channel. Please like, subscribe, and until next time, thank you for watching.